Innovative global integration personnel have over 70 years of combined financial industry experience with global financial institutions. IGI's primary goal is to consolidate data architecture, upgrading current systems while providing flexible, scalable, and upgradable data architectures. The Protocol Transformation Engine Dynamic Network Architecture, PTE DNA, is designed to minimize code and maximize focus on the business process. This is accomplished through the complete use of metadata, data about data. The term protocol, as used in computer systems, is defined as a set of rules and regulations that determines how data is transmitted and interpreted. This definition appears confusing to many people. To simplify this concept, the term protocol can be said to be any set of rules to communicate information. Everyone does this all the time. Every time you speak, you are using a protocol, the language you are speaking. Human beings use many languages and many ways to communicate with each other. We communicate as we speak. If we are sitting with each other having a meal, we may also use gestures as part of the communication protocol. 50 years ago, talking to each other remotely required a hardwired device. We would have to be in a physical location of the telephone to call someone. Today, virtually everyone in the world carries a smartphone with them wherever they go. These devices allow us to communicate with protocols other than just language. We can take and share photos and videos. We can use these devices to send emails. The PTE DNA architecture enables distributed processing systems while maintaining dynamic central management. Let's take a look at an example process architecture, moving from testing to final production deployment. Each machine or host has two main processes: the application service and the monitor service. Both of these services connect to the service composition metadata. There are three processing engines in this example: the admin process monitor, the fixed trade capture client, and the fixed trade capture client failover. Both of the client processes will connect to the Bloomberg Trade Capture Fix service. The application service controls the system. There are two versions of the application service, both a console version for initial testing and a system service for production deployment. In our initial deployment, we'll use a single machine to run all of our processes. The first thing to do is to make sure that our services have been stopped. Open the service console and stop both the SignalR application service and the monitor service. Once the service is stopped, we can open the application service as a console application. It will display the name of the host, the IP address, and the service port. Now open the IGI PTE DNA Manager application and log in. The first page that appears is the status page. Select the configuration page and then select the host. In this case, ramfix1. Notice that there is only a single process selected. Open the Add Process list and select the other three processes: Admin Server Main, Trade Capture Failover Client, and Trade Capture Server. Then close the selection list. Select the Admin Server Main process. Note that there are two topics: Trade Client Monitor, Trade Client Monitor Failover, Open the host editor and copy the host name. Now paste that into the host property of the Trade Client Monitor. In the case of the failover monitor, we have a dependent host. This process will only run when the dependent host process is not running. In this case, we will set both to be the selected host. Now select the Trade Capture server and start it. This will send a Start Application message to the application monitor on the desired server. Once it has been started, let's go check and see that it's running. Now that we've established it's running, let's start the admin server. This will control the other two processes. Now let's check our server again. Note that both processes are now running. The admin server will monitor this. The admin server's monitor processes control when the client processes run. See the initialization metadata tutorial for more details. Now let's return to the status page. Open up the filter dialog and select our host. Click the refresh button. This page displays the current status of all processes. Select the Trade Capture Client process, then select the Console tab. The Console tab creates a channel to the selected process's host and then displays its console output. If we select the System Console checkbox, we will get all of the processes on the machine's system output. Now go back to the Process tab and select the Trade Capture server and validate its console output. We have now validated that our system is operational. We will now move on to distributing this over multiple machines. We can dynamically control how our system runs and change its structure without having to change any code. In our example use case, we will distribute this processing across 3 machines. Move back to the Configuration tab and stop the processes that are running on our test. By moving back to our remote desktop session, we can see that our processes have now been stopped, and only the application console is running. Now remove the 3 processes that we added for the single instance test. Select the host that will run the admin monitor service and the emulation for the Bloomberg server. Edit the host in our Trade Client Monitor and Trade Client Monitor failover. Use the same host we had for test to run our main client. For our failover process, set the dependent host to the main host that we just set, and the failover host to the 3rd machine. Validate that our 3rd host has the failover client process available. Open the RDP session to our server. Stop both of the service processes. When that is complete, open up the application console service. Once again, this will display the information for the specified host. We will repeat this process for the other two hosts in our system. Stop the system services, and then start the application console. And finally, the same process on our third machine. Next, start the Bloomberg emulation server. Once our servers are running, it is not necessary to have the RDP session. We can actually monitor what is going on our servers from our status page. By selecting the desired process, we can check the time to validate that it has started. For this tutorial, we will now go back to our remote desktop session and validate that our process is running. Select the main host and then start the Trade Capture client process. The RDP session for that host will now show the client running. As will the server and the Bloomberg emulation. This same procedure can be accomplished by using the Status and Console tabs of the PTE DNA Manager. Return to the Configuration tab and stop the main client process. Select the failover machine and start the failover process. Return to the Status tab and select the emulation server process again. Now select the failover host and validate that its process is running properly. Return to the Configuration tab and stop the failover process. Now that we have validated that both the main and failover processes are operational, select the main server and start the admin process. This will now control both the main and failover processes. Let's check that our main process is running. And validate that the emulation server is processing correctly. Now that we know that our system is operating correctly, we can transition our host machines to use the system services. Go to the Configuration tab and stop all the processes on all the hosts. Select each RDP session and start the system services on each machine. Return to the manager and start the Bloomberg emulator process. All processes on our system are now running at the system level. This will ensure that even after a machine crashes, it will restart all of these processes when it reboots. The only way we can now monitor the system is to use the console in the PTE DNA Manager. The PTE DNA Manager also provides the Fix Messages tab. This provides tabs to view both the MBWD and trade capture data. The Trade Capture tab provides view of all trades placed by the system. Trades can be filtered. For instance, we can view all successful trades. By selecting any individual trades, both its request and response information is displayed. We can also find a specific trade by using its trade report ID as a filter. The third way to filter is to find all the trades for a specific security ID. PTE DNA provides the tools to easily manage, reconfigure, and maintain your systems.